All right, so now here are my three examples that we're going to graph. So the first one is -3 is less than x. X is less than or equal to +3. So remember what that means. That means that x is greater than -3 and x is less than or equal to a +3. So when I graph this, let's look at what I have. I have x is greater than a -3. So you know that greater than is an open circle. So let's write that, open circle. And it's greater than, so it's going to shade to the right. So let's look at what we have. Open circle. Greater than means we're going to shade to the right. This time I'm just going to use the same color for right now, just so that you can see the point of what I'm doing. All right, next we have x is less than or equal to a +3. So remember, this is closed because it says equal to. So I'm going to go to +3 and I'm going to close my circle. And I'm going to shade less than. Remember where less than shades? To the left. So I'm going to do this. And you'll notice that what you have done is you have created these two that overlap each other. Look at those two solution sets. You have one that's shading to the right, you have one that's shading to the left, and then they overlap each other. So what happens is the part that overlaps is your solution set because it is an and. And means only what they have in common. So the only part that can be the solution set is from here to here. Only that stuff that got shaded by both the less than and the greater than. So when I write my answer, that's why I have -3, because -3 is the lowest, +3 is the highest, and my x is trapped in the middle. So if you wanted to like shade all of this, normally if I had regular paper I would use a highlighter and show you. I know that's not real attractive, but it's showing you that that stuff in the middle is how you make your solution set. That's what the solution set means. Now, can you write this in set builder notation? Absolutely you can. To write this in set builder notation, all you have to do is add your little squiggle braces in the front, x such that, there you go. That is set builder notation. Already done. All you got to do is add the little squiggle with the x in the line, and it's done for you. All right. So now let's do the next one. 1 is less than or equal to x, and x is less than or equal to 7. What does it mean? It means that x is greater than or equal to 1, and x is less than or equal to 7. So when I go to graph this, what you have to look at, you have an option here. Both of these are closed circles. This one's closed because it has an equal to. This one's closed because it has an equal to. All right, so let's go ahead and shade this. Because what you're always going to see is you don't see one's a negative, one's a positive every single time. Sometimes you have negative here. Sometimes you have positive, positive. Sometimes it crosses the zero. Sometimes it doesn't. Every answer is unique. All right, so we have greater than or equal to +1. So that shades this way. Okay. We have less than or equal to 7. Closed circle. That shades that way. And then, if you look at what overlaps, okay, what overlaps from here to here. So all of this business in the middle, all right? So that's what you are graphing. This stuff right here, from 1 through 1, 2, 3, 4, 5, 6, and 7. You're graphing all of those numbers right there that make up the solution set to your problem. All right, let's look at the last one. You have a -5 is less than x, and x is less than 2. What does it mean? It means that x is greater than negative 5 and x is less than 2. Less than, not minus. All right, now look at my signs here. I do not have an equal to under either one of them. So both of these are open. Can that be possible? Yes. Okay. So what I've done here is I've given you an answer, a solution for each option. You can either have the first answer where 1 is an equal to a closed circle and 1 is an open circle. And it can be here open, here closed, here open, either one. I just wanted to give you one of them so that you could see. You could have an option where both of them are closed. Or you can have this last option where both of them are open. I'm trying to give you one of each different style of the answers that you may see. All right, so now let's graph this. We have greater than negative 5. So go here to negative 5. It's an open circle. So here's my open circle, and I shade this way, infinity. And then I come over here to positive 2. Positive 2 right here. And I'm going to draw a circle, open circle, shade. And then I mark my solution set. So my solution set starts there, stops there, and it's all of this ugly business that's in between. So X is trapped in between there, okay? All right. So we've done a lot with inequalities. I hope that you've learned something. And when we come back, we're going to learn how to graph not on a number line, but on the coordinate plane.